Hi, today we'll see how to solve the partition list problem in Leet code. So we are given a list and we are also given a value of x. We need to return the list in such a way that all the nodes with value less than x are at the front and all the nodes with values greater than or equal to x are at the back and their relative positions shouldn't change. Now let's see how we can solve that. The idea that I've used to solve this was taken from quicksort. So in quicksort, we have a pivot, and once we have a pivot, we divide the list into two simple lists. One containing all the elements less than pivot, and other containing all the elements greater than or equal to the pivot. So I tried a similar idea. So for that, like I've said, I've created two lists. Okay. So this is list one. We can call it as like lower, all the values lower than. So this is lower list head. Okay, and I'm giving its value minus 300, just so that the value does not coincide with any of the values of the nodes. And I'm creating a second list, and this is higher list, and its higher head. Okay, and its value is minus 300 as well. Okay, now we start from here, from the top of the list, and check whether its value is less than or greater than or equal. So 1 is less than 3. So what we do is we take that node and add it to the lower list. Okay, now that we've added 1, we need to remove the link between 1 and the next node. If not, the link will be maintained and it will cause issues. So what we do is, after we add 1, we sever this. Okay, sever this link. We make that like node.next equal to null, so that this link will be. Now we are at 4. Again, 4 is greater than 3, so we add 4 to the higher list. Again, we sever this link so that we don't want the next element to be attached to 4. Now we are at 3. 3 is greater than or equal to 3, so we add 3 here. Sever the link. Now we are at 2. 2 is less than 3, so we put 2 to the we add 2 to the last element. Okay, now sever this. Now 5 is greater than 3. We add 5 to the last element in this list. Sever it, and then we have 2 less than 3, so we add it here. Now we have two lists. What we do is we create a connection between the last element of the lower list and the first element after the higher list, which is this. Okay, and we return the first element after the lower list head. Anyway, this head is something we created, so we return the pointer to this. Okay, so if we see, the output is 1, 2, 2, and 2 will connect to 4, 3, 5. And as we have done everything in one go, the time complexity is O of n. Okay, O of n time, and no matter how long the list is, we only create constant extra space, that is one lower node's head and higher node's head. So the space complexity is also constant. Okay, now let's review the code. As you can see, I am creating left head as specified and right head. Here I am having as higher head, and left current instance, which a pointer to the last element in the left list. Currently it will point to the first ones. Now the iterator is at here. We check if it's less than x, then we add it to the last of the left list. So I've added here. If not, we'll add it to the add as the last element to the right list. Okay, now once we are done, what I'm doing is, if the last element of the left list is not 300, which means there are some elements in the left list. Okay, if it's 300, it means the node that we've created and there are no elements. If it's not 300, it means there are some elements. So we need to return this, right? Starting from here. So result head something. So result head dot next. I'm just creating a node called result, and for that I'm attaching the element next to the left head. Okay, left head dot next. So it's 1. And to the end of this list, which is left current dot next, I'm attaching right heads next, that is 4. Okay, and similar, if the first element is 300, then what I do is to the result I attach the element next to the right head, because there are no elements here. The end of the left list is 300, which means there are no elements, and this is the end. The head that we created is the end. So what we do is add this to the result, okay, and return it. I guess that's pretty much it.